In this video, we are going to solve some problems based on rotational motion. Let's look at the first problem. A disk initially rotating at 5 rads per second experiences a constant torque for 4 seconds that results in an angular acceleration of 2 rads per second square. The angular displacement of the disk during 4 seconds is most nearly. So for this, first we need to write the data which is given to us, and then choose kinematic equations. Choose one of the kinematic equation to solve it. So first let's look at this initially rotating. That means this should be theta I, which is 5 rads per second. Then angular acceleration is given to us, so that's alpha, 2 rad per second square. And then we want to find out, and also the time is given to us, which is 4 seconds, and we want to find out the angular displacement, that is delta theta. I think I did a mistake here. This is not omega theta I, this is omega I. Yeah, it is rad per second, so that should be written as omega I. Theta is for position, angular position. Okay, now we want to find delta theta, that is angular displacement. So we have to choose one of the kinematic equations which can be used with the data which is given to us. So the one which I'm going to use is delta theta is equal to omega t plus half alpha t square, which is omega I t, initial angular velocity, multiplied by the time, plus half alpha, which is angular acceleration, t square. So let's substitute the values here. 5 multiplied by 4. I'm just substituting the values from the data which I have collected from the problem, plus half times 2 times 4 square. That should come out as this will be 20 plus 16, which will be 36 rads or 36 radians. That's our E. Okay, next question is based on torque. We have got a diagram here. A bar of length 1 meter sits on a pivot. This is the pivot located at its center. At the instant shown in the figure, the bar is horizontal and two forces F1 and F2 are exerted on its ends as indicated. We can see there is one force F2 here and one force F1 here. With respect to the pivot point, what are the magnitudes tau 1 and tau 2 of the torques due to forces F1 and F2 respectively? So we want to find what is the torque because of these two forces. So we can see that F1 is passing through the pivot. So obviously the torque due to F1 has to be 0. So once again, remember to be very clear about where is the pivot point. So we can just highlight it. I've just highlighted it, where is the pivot point. And then think about the force. Look at the force and draw the line of action of the force. If I just extend this line of action of force, I can see that it's going to pass through the pivot. That means it has no distance from the pivot. So its torque will be equal to 0. Now for F2, we can see that it's at a distance of 0.5 meter. It's making an angle of 30 degrees. So we can just use the formula. Torque is equal to Rf sine theta. R here is the distance from the pivot, which is 0.5. F is the force itself, which is 40 times sine 30. So that should come out as 10, and the unit is Newton meter for torque. So that's our part A.